haters, grade 11s. You guys were in grade 10 last year, now you're in grade 11. So welcome to Maths. It is a Monday and you're hanging out with Looney and Dina. Dina, how are you?
Doing very well, doing extremely well, and even better for seeing you and everybody that's watching.
All right, so what are we doing for the grade 11s today?
Grade 11s, we're going to start off with that very famous topic, exponents. We're going to look at today some expressions, simplifying expressions, and next week we'll look at some equations.
All right, cool, grade 11s, you heard it. I hope you guys are excited because it's your first live lesson for 2014. Just a reminder on where to get us and how to do everything. Add Learn Extra on Facebook and Twitter. That's where you follow us and like our page. And then you can go to learn.mindset.co.za to get your notes, to see the schedules, and to see all the videos for the lessons. Okay, guys? So I won't waste any more time, and I'll take it straight back to Dina.
Well, as I was saying, we're going to be looking at some exponents and some surds, some work that you've done previously, and also perhaps some new things that you'll be learning this afternoon. So let us find what we're going to be doing in the lesson today. So in this lesson, we're going to simplify expressions using the laws of exponents, and we're going to also add, subtract, multiply, and divide some simple surds as well. And whenever you do surds, you're going to not be using a calculator. So we're going to see how that all works. Then this year, we'll start off with our challenge question. We're going to first provide you with some really interesting questions that you can be working through while we're working through the various segments, and at the end of the show we'll see if you were able to get it. So the challenge question is to simplify that fraction, 5 to the power of 2014 minus 5 to the power of 2012 minus 24, all divided by 5 to the power of 2012 minus 1. Let's see who's got the fastest finger and can post their answers the quickest. While you are working on that question, we're going to take you firstly through a little section on the summary of the notes that some of you may have already been doing in class, and then also one or two of the questions. So let's look at some of our exponential laws. Our laws are really centered around products and quotients. The exponential laws around the sum and difference of terms don't exist. And I find that the biggest problem with this section, or that students battle with, is really understanding that there are laws for products and factors that don't work for the sum and difference. And if you really try and analyze the kind of question you have in front of you and ask yourself, am I dealing with a product or am I dealing with a sum, then I think your work around exponents will be a lot more simplified, because you'll know when to apply the laws. So what I find that students do is they use the product laws when they're doing additions, or they'll use addition laws when they're doing products. They're not working with the correct law. So you really do have to pay attention and understand that the laws work around the product of the same base, which means we're dealing with one term. So the law is around the product. So I must first establish, have I got a product before I can jump into that law? And over here, you've got the quotient. So here, it's the quotient rule. Then you've got another slightly different looking law, and that is when a power is raised to another power, then if you really had to rewrite it, it would be something like this, times a to the m, times a to the m, n number of times. So you really are looking at that law all over again. And then we deal with this law, which says that the product of a and b raised to the m means that each factor, a to the m and b to the m, each factor a and b is raised to the m. Now, you are going to be required to go sometimes that way if you're raising a power, and sometimes we want to go from there and we want to factorize into one power only. So don't only think of the law applying in one direction. You may have what we call same exponent being multiplied together. Notice again, it's the product. there are no sums here. So I do not have a to the m or a plus b to the m. What does that mean? And I feel that students don't engage with the language of what it is that we're trying to do. So here we're multiplying a times b. We're not adding a and b. So if you were adding a and b raised to the m, what would you do differently? How does the law apply then? Does this law apply? Or is something else in operation there? So we're always aware, am I multiplying, am I adding? Because the laws for addition and the laws for multiplication are very, very different. Okay, then we can actually go down here and just see. The other very famous one is one you've done in grade 9, and that is that an a to the 0 is always equal to 1, or any base to the power of 0 is 1. And then the definition of a negative exponent, which is the reciprocal of that power. So a negative exponent always tells us that something, that the power, you are going to take the reciprocal of the power when you place it into a positive format. Okay, so I think those are very common. Where the problem comes is in the application of it, and we'll look at it later, how we can stress the importance of the products and the sum. Now, this looks a little bit incorrectly written. Let me just rewrite that. That should say a to the power of m over n, which means that you have a rational exponent. Rational exponent means it's a fractional exponent. So this will exist when our base is positive and when m and n is a rational number. So what does each one mean? We've got here that n is the nth root and m is the power. Now the nice thing about remembering how this works is that this denominator always refers to the root. And if you remember, roots in biology, they grow underground, which means that that will always stand for the root that you're working with, whereas the m is the power that a is. So we could rewrite this as a to the m, all the power to the power of 1 over n. So that's the nth root. And you'll see on your calculators, some calculators have got that 1 over n button, which is the nth root. So what is our special note point here? Exponential laws are applied when working with products and quotients. There are no laws for the difference, sum and difference of exponential terms, except the one I showed you earlier. What would you do if you have a plus b to the m? Would you do anything with it? And we'll see a little later, quite a lot of the questions involve the sum. What do you do with the sum? So even though we're saying no laws, there is something we can do with it, but there's no exponential law that you do in the section to be able to cope with it. We've got to go and find it elsewhere. Okay? Right, so for example, if we had a plus b and we were squaring, what would we be doing in order to get to that product? Well, first question is, what does it mean? If you see a plus b all squared, would you take our law for products, which says a b all squared, and would you then say that that's equal to the same thing, which would be to square a and to square b? Would that be true? And I would love to have you commenting on Facebook and just telling me, what do you think? Is it true? Isn't it true? Do you agree? Don't you agree? What do you do when you see the product versus the sum? What do you do when you see this sum, a plus b all squared? Well, it's critical that you answer the question, what to understand by the meaning of this term. So the meaning is that we actually have a plus b multiplied by a bracket. So we've got this complex term, a plus b, and we're multiplying it out like that. And now we're sitting with the product of two binomials. So when we square them, we actually have the firsts, which is a squared. Then we have the middle term, which is AB, and we've got another AB. So we've actually got 2AB. And then we've got the lasts, which is the B squared. So we've got the sum of two terms and we're squaring it. We actually land up with A squared plus 2AB plus B squared. That is the most classic error that anyone can make, is to see A plus B all squared and to square the two things they see. Because the two things they don't see, the AB times the AB, they don't see it. It's there, it's hiding inside, but you can't see it. So out of sight, out of mind, I'm afraid. And whenever you are squaring anything in maths, you need to ask yourself, is it the product? Is it the sum? Because if it's the sum, then I must write it out as a sum of two brackets that are being multiplied together. And if it's the product, then I can also write it out and see that I actually get the same exponent for those two factors. So only the factors get the exponent and nothing else. So my biggest issue around working with exponents is that you must analyze and scan the question before launching yourself into it, and to ask yourself, do I have a sum, do I have a product? Because the rules are very different in each case. So tips for answering the questions: I need to analyze all the questions first, and I need to scan. This process of analyzing will prevent you from doing silly mistakes for the type of expressions they contain. Think through which laws you would use and why. Which am I going to use and why am I going to use them? So when you're looking at the example, that I've just set up, what is the difference between the two questions given below? So have a careful look at what the difference is between the square root of a to the power of 3n times a power all squared versus this question, 2n plus 4 minus 6 times 2 to the n plus 1 divided by 5 times 2 to the n plus 2. So you might say to me, Dina, I can see the difference is one is a product and the other one is a division. So in the one question you're multiplying, the other question you're dividing. That's very good. But there is another very major difference between these two questions. There is something different that you would do in the first one as opposed to the second one. And for those of you, I should give out prizes that can see that, it would be this subtraction sign over here. So in the first question, there are no pluses and no minuses. There's no sum, there's no difference of terms. So I'm going to be launching in a question where I can use the exponential laws. But in the second question, I have two terms. I have that minus sign separating my two terms. Grade 11s, that is your little alert bell. It's alerting you to saying to you, hang on, I'm here because you are going to deal with me differently from what you were doing in that first question. Here, the moment you have a negative sign separating those terms and you have a division, you now have no option but get your expression into factors. So you are going to factorize. So we're not going to apply the laws of exponents and say, okay, we see the same base, therefore we're going to subtract exponents. We're not going to do that. You have to first analyze and decide what type of expression you're dealing with. Is it just a matter of multiplication? Or are there sums and differences? In grade 11s, you will really improve the quality of your work in exponential work if you are able to first scan into what type of question you're dealing with. So I would, when looking at these two questions, I would always start with number 2 first, because that question is the one that is different. So start with the differences, because then when you're doing the second one, you can really go in automatic in terms of exponential work, because all your laws will apply in that case. Right, so I think that on that note, we'll give over to Luni.
All right. Mindsetters, we are going to take a break. Like I told the grade 10s, grade 11s, if you know any matrics who want to sub their matric from last year, we do have sub school from 9 o'clock, and then it stops when the live shows start, and then it continues on when the live shows end. So please tell your matric friends if they want to redo some of their subjects and they need help. We do have sub school to help them revise and go through questions that they need in order to write the SAP exam. Okay, guys? So make sure you tell your matric friends if they need to know that information. Right now, we are going to take a break, so don't go anywhere. We'll see you straight after this. Welcome back, Mindsetters, from that very first break of your lesson for grade 11. Just to tell you guys, some of you are confused with the challenge question if it's 24 or 25. It is 24, so don't mix it up with 25. It's 24. Quick shout out to Apiwe, Klapo, Tatos, Busiso, Fortune, and I just saw another one, Jabulile and Dawit. Thank you guys for tuning in. Hope you guys are enjoying the lesson. I won't waste any more of your time. I'll take it straight back to Dina.
Right, grade 11s, I need you to be extremely active on this show. You've got the challenge question. I want to know what you're getting for that challenge question. Plus, in the notes that you can find on the link, you will see 10 questions that I would like you to try. Some of them I've already dealt with in the lesson already. I want to see how many of those 10 you can get out. So quickly get those out while we're in the break and try them. I want to know in the last segment, I want to get your queries on those questions. And if you don't do them, then I haven't got a segment and I'll feel very sad. Come, everybody, let's work on those 10 questions and get them in. While some of you are working, the others are really keen to hear how to simplify expressions, especially the ones where we've got the minus and the plus signs, because those are my favorite. Why? They simply require you to do something very different from just exponential laws. So let's get to one. If we're given that a is a fraction 3 to the n minus 4 divided by 6 to the n minus 2 to the n plus 2, how would we simplify n? And I'm just going to edit this slightly, because this numerator should actually say 3 to the n minus 4. And while I'm on the topic of rewriting things, grade 11s, you need to use 2 of your blue lines in your book. I'm trying to prepare you for that final grade 12 examination as well. Use 2 lines for exponents. If you only use one and you try and draw a fraction line, then your exponents become very squashed, and this is what happens. You actually see a 3 as a coefficient and an n as a literal factor, rather than n as the exponent. So we need to really use 2 lines and make sure that we can see those exponents clearly. Now, if you look at this question from the 2 that I gave you in the previous segment, what would you notice when you analyze and you look at it and you scan for the important issues? What is it that you see? Straight away, we notice that it's got terms in the numerator, it's got terms in the denominator. So I'm going to factorize. I'm not going to use my laws for my exponent just yet. I'm going to factorize. And that prevents me from getting into the trap of saying 3 goes into 6. Because the most common error that grade 11s do is that 3 to the n divided by 6 to the n is that they say 3 goes into 6 twice. And that n goes into n, and we've got this floating 2. And that certainly is not true. You cannot divide base by base. Cannot split the base and the exponent. So we cannot divide base by base or exponent by exponent. Okay, so that is the greatest mistake, the most often mistake. If you ask your friend to do that, you'll see what they do with it. Okay, so the only thing you can divide is if we have 3 to the n divided by 3 to the n. So we've got the same base and the same exponent. Then we're dividing the power by power. So you can divide power by power. In other words, the base is the same, the exponent is the same, then I'm dividing the whole unit. I'm not splitting it. I'm not saying the base divided into the base. It's the whole unit. Now, you've been doing it ever since you were in grade 1, when you were dividing 6 by 3. That 6 was to the power of 1, and 3 was to the power of 1. So, in effect, you were dividing 2 numbers that had the same exponent. So that's what we're doing here. We're making sure that the exponent is the same before we can divide. But you can never, ever divide just base into base when the exponents are different. Okay, so now we're going to simplify this a, and we're just going to go down a little bit. Where's my page? How do I go down on my page? Oh, there we go. Right, so my question is this. A is 3 to the n minus 4, and I'm dividing it by 6 to the n minus 2 to the n plus 2. Grade 11's our job is to try and get same base, same exponent in order to be able to factorize. So, if we look carefully, analyze, we've got a 3 to the n, we can't do anything with it. Here we've got this term with a 2 to the n plus 2, where we could actually split this because the sum of two exponents from your exponential law comes from the splitting up of your exponents into their bases. So when you have the sum of exponents, you actually have started with a product of two powers where the base is the same. So if I go from there to there, what would I say? I'm multiplying, same base, so I add my exponents. So you're interchanging. And why I like this format is because when you factorize, you must have base and you must have exponent. Now, that's also okay because that's base 2. If I look carefully at this term here, it's a 6. And a 6 is made up of 2 times 3. So any work around exponents, we like to reduce our number of bases. We've got a 3, we've got a 2, we've got a 6. But the 6 can be written in terms of 2s and 3s. Every number in our number system can be written as the product of primes. So we were going to take any number that is not written as its prime bases into primes. So 6 would be written as a 3 times a 2. And we're then raising it to the power of n. What is the law around product? Because remember, they're product laws. 3 times 2 to the n is the same as 3 to the n times 2 to the n. And then we have this fraction, 3 to the n minus 4, divided by 3 to the n times 2 to the n in the denominator, minus 2 to the n times 4. And now we'll see, in the numerator, there's nothing I can factorize. But can you see what's happening in the denominator? Is that we've got this common 2 to the n. And look what I'm going to take out when I factorize. Same base, same exponent. I don't split. I don't take away bases and say they're common. You cannot do that. You're breaking a number into something that it is not. So we now have that common factor. So we can say our numerator, I can't do anything with it, but our denominator I can. I can take out that common factor 2 to the n, and I'm left with, taking out a factor means I'm dividing by that, so that becomes a 1, so I'm left with a 3 to the n, and I take that out, so I'm dividing by that, so minus 4. Grade 11s, I hope that when you factorize, you actually say 3 to the n times 2 to the n. If you're dividing about 2 to the n, that goes in there once, and so we are left with 3 to the n. So when you multiply it back, you're going to arrive right back at that one. Can you see what you now have is that in the numerator, you've got 3 to the n minus 4, which now divides into that. So we're left with, that goes in there once, so I'm left with 1 in the numerator, and I'm left with 2 to the n in the denominator, which, if I had to rewrite, would just be a half to the n. Notice that 1 to the n would just be 1, so that's where that 1 comes from. But be aware, grade 11s, you wanting to be good on your speed and accuracy with this work, so that means exactly the same as that. I'm making an issue of that 1 over 2 to the n because you're going to sketch it in your graph section. Remember, it's an exponential. You sketch exponential graphs. So you will be sketching that 1 over 2 to the n, which is the same as a half to the n. Okay, so let's now see what was originally part B of that question, was to rewrite it, the answer, as in this format. So we now have a equals a half to the n. And the question said, please rewrite this as in that format. What would it look like? Okay. We now have an exponential format. And how would we write it as a root? We would take the root on both sides. So if I have a equals a half to the n, and I now take the root on both sides. I'm going to take the root n on both sides. Then when you take the nth root of a number, you undo the root. So root of n would be just equal to a half. So that value was just equal to a half. So remember, the n stands for the nth root, and in order to take the nth root of a, we would have to take the nth root on the right hand side as well, so we would then get just a half. Right, so that would be our first little question for the afternoon. Okay, let's work with some surds. We haven't done any surds yet. We've been given a rectangle. So this length here is equal to that length. And that length is root 5 plus 1. And we've been given that length and that length. They're the same. And since it's a rectangle, that's root 5 minus 1. We have that's a right angle. So it's a rectangle. I've just put in the properties of a rectangle on it so that we can see what each of the lengths are. We would like to calculate the length of the diagonal and leaving that answer in surd form. The diagonal goes from vertex to vertex. So our job is to find out what is x. It doesn't have a length, so let's give it x. And we need to leave the answer in simplest surd form. Okay, since it's a rectangle, we've put in the properties. We've got a right angle, so this x length is now the hypotenuse of that right angle triangle. So to find x squared, we would now have the one length, which is root 5 plus 1 squared, plus root 5 minus 1 squared. Now we're working with the surd. This root 5 is known as an irrational number. It's known as a surd. Surds operate with the same laws. They are governed by the same laws as algebra. So we would get like surds if they contain the same surd value. Or we would work with root 5 times root 2 as root 10. You would multiply the two surds together. So the relationships that you've learned in algebra apply to surds. So now that I've got to square this bracket, we're going to get squaring a bracket means the square of the first, and square root of 5 times square root of 5 would give me the square root of 25, which in rational form would just be 5. Then remember that when you're squaring a bracket, you've got the doubling up of the product of the two. So it's root 5 plus root 5, which would be 2 root 5. And then we've got this plus 1. We're also squaring that binomial. Root 5 times root 5 would just be 5. Double would be minus 2 root 5, and we've got this plus 1. So we have a 2 root 5 minus a 2 root 5, which is 0. We've got a 5 and a 1, which is 6. 5 and a 1 is 6. So x squared is 12. So let's just get our work back. Okay. X squared is 12. So x is equal to the square root of 12. How do we get surds to be in simplest form? You need to extract any square root, any perfect squares that you see in those numbers. So the square root of 12 is the same thing as the square root of 4 times 3. So the square root of 4 times the square root of 3 would now give me 2 root 3. And this version of root 12, where part of the number is rational and part of the number is irrational, is what we call a simplified surd form. To get a surd into its simplest form means you're going to rewrite the number without any perfect squares in them, because the perfect squares become rational, and that makes it into simplest surd form. Now you will find that you're going to be adding 2 root 3 to another 2 root 3, for example. So if I had a 2 root 3 and I added to 5 root 3, we would call these like surds, because they contain the same surd portion. So that the rules for algebra would be we would add the coefficient, so we would get 7 root 3. So once we have got every single number into simplest surd form, we would then just add, like we would add in algebra, like we would subtract, divide, and multiply as well. The only new thing about irrational numbers is that if I was squaring root 12, then I would say that that is root 12 times root 12. So I would get 12 12s are 44. I would get the square root of 144, and that would just be equal to 12. So when I take an irrational number and I multiply it by itself, I get the rational version of that number. That's the only law around irrationals that you would have to look at. Okay, so just to check that we've looked at the diagonal and we've given it in simplest surd form. Right, grade 11s, let's see the last little question in the segment. And that is, how do you simplify an expression that contains, watch it carefully, plus minus plus? What are you going to do, grade 11s? By this stage, you must be able to tell me what you would do when there are sums and differences. But I also notice that I've got a root x, but I've got an x to the half in the denominator. In that case, we are going to rewrite our surd into exponential form. You will not write that surd into exponential form if you've got other surds lurking about. But in this case, everything's got an exponent except that little root x. So the first thing we're going to do to it is that root x means the same thing as x to the power of 1. The root is 2. Remember, a square root doesn't have a 2 there, but the first root that we get is the square root. So we actually have 2x plus 7x to the half minus 15 all over x to the half plus 5. Now, grade 11s, you must also be a little bit smart about how questions are asked. If I'm asking you to simplify a quotient, I'm saying, please, won't you divide that won't you divide that divisor into that dividend? Then your job as a mathematician is to say, well, that thing in that denominator must be a factor of the numerator, okay? Because otherwise, I'm not going to be able to simplify this. I must be able to divide that whole x to the half plus 5 into that numerator. So this numerator over here must be able to be written as the product of factors, one of which must be x to the half plus 5. It makes sense that that factor should be there. Otherwise, it's not possible to divide. So notice carefully that this is a trinomial where my middle term is x to the half. That is a clue for me that my first term must be 2x to the half, x to the half. Here come your powers, your algebraic powers, to be able to factorize. That x to the half times itself will give me x to the 1. So a very important tip, x to the half times x to the half, same base, keep the base, add the exponents, half plus a half. Don't get tempted in multiplying these things, which is x to the 1. So my middle term always tells me what the first two factors are going to be. Then I need factors of 15. So I need a 5 and I need a 3. And lastly, we need to think about our signs. I want to get a plus 7. How am I going to get a plus 7 out of that? I'm going to have 5 2s are 10, and I'm going to get a 3. So I want to get a 10, a positive 10, minus a 3 to give me the 7. Ah, look at it. I have factorized it, and I'm actually getting that factor in there. That's exactly what I wanted to do. I wanted to be able to factorize, because when there are terms, I need to factorize. There are no other options, grade 11s. If there are terms, I must go and factorize. I won't be able to get out of that jungle without factorizing. So in the end, we have that goes in there, and we're left with 2x to the half minus 3. So we're only left with that portion. Right, grade 11s, I'm hoping that after the break we're going to have all your answers to that multiple choice question. I want as many questions from you as possible. Over to Luni.
All right. Mindsetters, we are going to take a very quick break, so don't go anywhere. We'll see you straight after this. Welcome back, Mindsetters, from that break. I see there's a lot of answers for the challenge questions. Dina, did you say we're going to do that now? So we are going to go through it. Lots of answers there, guys. So yeah, hey, Dina, please help us.
Wow, I was watching Looney there, and she was just scrolling, and there's zeros and 49s and 15s and all sorts. So let's see. Now, I know what you're thinking. You thought that you could just use your calculator. But the thing is, 5 to the power of 2014, 5 to the power of this year, cannot be calculated on the calculator because the calculator is too small. Its capacity is too small. It can't cope with that massive number. So we must find a very smart mathematical way of being able to work with this 5 to the power of 2014. Now, Mindsetters, let's see how good you've been with today's information. What is unique about this question? What do you see that is going to put on brakes and you're going to say, hang on, I need to pay attention to that very special mathematical statement? What is it about that statement that's special? Well, we notice straight away that we have this negative, and this negative. So I am going to be factorizing. There's no other way of being able to divide unless you have factors. So I've got this massive 5 to the power of 2014, which your calculator would not cope with. And I've got this 5 to the power of 2012, which it also can't cope with. What do you notice about those two terms? That is there are 2012 factors of 5. This one's also got 2012 factors of 5. So if we had to factorize those two pink terms, we would get 5 to the power of 2012 as my common factor. How many factors are left in 2014? Well, times another 5, times another 5 to get to 2014. So there is a 5 squared. Okay? I have taken the whole of 5 to the power of 2012 out, so I'm left with minus 1. And I haven't done anything with a minus 24 because I can't do anything with a minus 24, so it stays waiting for the next section. And then I've got this 5 to the power of 2012 minus 1. Can you imagine if you had to sit and write 5 times 5 times 5, 2012 times? Can you imagine how long that would take you to write out? Aren't we just so special as mathematicians that we can have this very shorthand way of being able to write so many values in such a short space, Right. Now, there is something I can do here. 5 to the power of 2 is 25, minus 1 is 24. So I've now got 24 times 5 to the power of 2012 minus 24, divided by 5 to the power of 2012 minus 1. Right, Mindsetters, I'm still sitting with negative signs, so I can still factorize. As long as I haven't got one factor out, I am going to be factorizing until I get it. So I've now got a common factor of what? Is this 24? So I'm going to take out 24. What am I left with? 5 to the power of 2012 minus 1, divided by 5 to the power of 2012 minus 1. Now I have this complex factor, this bracket, that I can divide into the numerator. And what am I left with? if I divide that bracket into that bracket, I don't need my calculator. I've used algebra, and I'm able to get a final answer of 24. Now, Looney, who was that smart little child who got 24?
There was not just one smart little child. Like a majority of them got 24.
Oh, good.
Yes.
I'm glad that quite a lot of you got 24, which means that you were really factorizing, because your calculator wouldn't have been able to give you those very large numbers. So well done to all those who were able to get the challenge question out, and I'm hoping that you'll go into the notes. The notes will be ready for you to go into for next week, so that you can do that challenge question and really post your answers. It's lovely to see all the activity on the Facebook page. Right. Do we have any further questions on the multiple choice?
No, we don't. No. Can I just send a shout out to the ones who said 24?
Yes, absolutely.
Okay. I'm Gelani. Okay, I'm just looking for 20. Wow, Rabison. That's a weird name. You said 24. Tumi Show, you said 24. Maneo, you said 24.
Nice one, Maneo.
Okay, there's so many mindsets, you guys, so clever. Costas, you said 24. Pretty, you said 24. Tabang, you said 24. Danica, Tabete, Josh, Siabonga, Vutivi, Dawit, and yes, thank you so much, guys. You guys are so clever. Half up to you.
And I'm hoping that if we had to go back and check your work, that you had factorized, that you didn't just guess and got rid of all those fractions and just said that 24 because 24 was in the answer. So we'll see how good you are for next week. Right, now we've got some test yourself questions that were in the notes. I'm hoping that some of you have been able to get through some of those. And the first one is to say whether the following statement is true or false. Grade 11s, is it true or is it false? 50-50 chance. We said earlier that we needed to analyze and to see whether we could apply the laws or not. So in today's session, you would have noticed that I've really focused on the sections that don't involve the laws, because everyone just jumps right in and tries and just applies the laws left, right, and center without considering what they have. And so you'll notice you cannot apply the exponential laws to this and say that it's a to the negative 1 and b to the negative 1. That is not true. That is absolutely false. And it's false because when you have two terms, then both of the terms have to be written as the reciprocal of the base. So it actually means that you have to divide 1 by the sum of a and b. However, grade 11s, if you had this, a times b to the power of minus 1, then would that be a to the power of minus 1 times b to the minus 1? Absolutely, because that's your exponential law on the product, not on the sum. The sum means that you have to look at the meaning of negative 1. The meaning of negative 1 says take the reciprocal. That's your base. A plus b is your whole base. Take the reciprocal of that. 1 divided by a plus b. So get the sum, and once you've got the sum, you then divide. What I find students doing is they don't know what to do with a plus b, so they start doing all sorts of strange things. But if it cannot be added, math says, algebra says, leave it like that. It cannot be added. That's how it stays. Don't try and force something that can't happen. Right, another true or false. Is 2x to the power of negative 2 the same as 1 over all over 2x squared? Do you agree with that, grade 11s? Would you say it's true? Would you say it's false? Well, we need to just write this a little bit larger so we can see what we're talking about. 2x to the negative 2. My question is, this exponent, where does it belong? Does it belong to the x or does it belong to the 2? This 2 here, as it stands, it says 2 to the power of 1 times x to the power of negative 2. So it says 2 multiplied by x to the negative 2, which means 2 times 1 over x squared. Because what does a negative exponent mean? It tells you it's the reciprocal of the base when written with a positive exponent. So if you did want this negative 2, if you did want it to also belong to the 2. What in mathematics says that we belong together? What is that one symbol that makes things belong together? Well, there's only one symbol, and that is brackets. brackets always say we belong together. If that was raised to the -2, then grade 11's, that 1 over 2x squared would be the correct answer. There would need to be a bracket around that whole thing. But if it's not, then this is certainly false, because the answer is it should just be 2 over x squared, because the negative exponent is only operating on x, not operating on a bracket of both those factors. So grade 11's, it's very important. Those maths accidents happen when you are not looking at what it's saying, what is it meaning. So read it, try and understand it, try and find out where do those exponents, where are they affecting the bases, where are the bases that they belong to. Okay, right, so that's another true or false. Let's see our next question. Next question, hello, there we go, right. Aha, here's another true or false. Is the square of this bracket equal to 5? Well, first thing, 9 to the power of a half. What does that mean, grade 11's? Half is the root, so that's the square root of 9, and the square root of 9 is 3. What is the 4 to the half mean? That means the square root of 4, and the square root of 4 is 2. So, if we rewrite it, then we have 3 minus 2 squared would be, the square root of 3 is 9, the square root of 2 is 4, so 9 minus 4 is correct. Are you in agreement with what I've just done, grade 11's? Would you say that is, are you happy with that? As mathematicians, we have that body of rules that says to us, if we all want to be getting the same answer, then we better following the same rules. If we all want to get to the same destination safely, then we must all follow the road rules. So rules are there to help us, to guide us arriving at the same destination. Now, what I've done over here is I have squared the 3 and I've squared the 2. Are you happy with that? I would be saying that if I had to redo this and say 3 minus 2 is 1 and 1 squared is 1, look at the problem, is that some of us are getting 1 and some of us are getting 5. And there's a massive contradiction. So if we had to apply this kind of maths in engineering, in medicine, some of us will kill our patients and some of us will destroy the bridges because we're getting different answers. Okay, so there's a huge problem over here. We need to be getting the same answer. Why is this person getting 5? Well, this person's getting 5 incorrectly because they are squaring terms, and terms don't get squared. If you've got something in a bracket, the order is perform the bracket, perform what's in the brackets, and then square. So let's follow those rules that we know about maths. Do the brackets first and then square. So if we had to say 3 minus 2 times 3 minus 2, what is this person who got 5 forgetting? They are forgetting that they have this FOIL, the outers and the inners. So you get a minus 6 and a minus 6, which is a minus 12. And so we have 9 plus 4, not minus 4. 9 plus 4 is 13, and 13 minus 12 is giving us 1. So if you follow the rules of mathematics, then we all get the same answer. This person's not following the rules. They're just squaring terms. And we don't have a rule for squaring terms. The squaring terms means add them together and then square, or then you FOIL. That's the rule. So they're not applying the rule. They forgot the outers and the inners. And that's what I've been showing you the whole lesson, is when you don't consider if you have terms or factors, you're going to land in that pothole, that big one, that mathematical pothole that just does not remember the outers and the inners in a binomial squared. So very, very important. What would you say 2 to the power of 1 minus 2 to the power of negative 1 is equal to? Is it equal to 4, 3 over 2, 2 to the 0, 2/3? What's it equal to? Well, 2 to the 1, there's nothing we can do with it. So 2 to the 1 would just be 2 to the 1. But what does 2 to the negative 1 mean? Well, some of you may say, oh, I've got the same base. If I have the same bases, add my exponent. So 1 minus 1 is 0. So my answer is 2 to the 0. Do you hear that language? I have the same base. Grade 11s, that's wrong. I need to first scan and see what's happening. 2 to the 1 minus 2 to the negative 1. If I'm subtracting, there are no rules. You have to work through what each of those terms means. So this person who is saying this answer is just operating from, oh, I heard some rules if it's same base. It's not about same base. It's about the product of same bases. Try and use the language correctly, and then you'll see your mathematics also improves. 2 to the 1 minus a half. That's what it's saying. And 2 minus a half is 4 minus 1, which is 3 over 2. So it's 1.5. So the answer would be B. So that would be that answer. Okay, let's see what our next one is. One more. Okay, let's just see if that was the next one. All right. Okay. I'll leave it at that. We'll send you back to Looney. Thanks.
All right. Thank you to Dina for giving us a great lesson. Mindsetters, thank you so much for tuning in. Grade 11s, it was an awesome time. Congratulations to all those millions of people who got the answer right for the challenge questions. Remember, guys, we did post the link to the notes on our page, so you can go through it again if you didn't understand. Take it slowly, and we will post the actual solution for the challenge question. Thank you so much for tuning in, and I'll see you next time. Bye, guys.
It would be something like this, times a to the m, times a to the m, n number of times. So you really are looking at that law all over again. And then we deal with this law, which says that the product of a and b raised to the m means that each factor, a to the m and b to the m, each factor a and b is raised to the m. Now, you are going to be required to go sometimes that way if you're raising a power, and sometimes we want to go from there and we want to factorize into one power only. So don't only think of the law applying in one direction. You may have what we call same exponent being multiplied together. Notice again, it's the product. There are no sums here. So I do not have a to the m or a plus b to the m. What does that mean? And I feel that students don't engage with the language of what it is that we're trying to do. So here, we're multiplying a times b. We're not adding a and b. So if you were adding a and b raised to the m, what would you do differently? How does the law apply then? Does this law apply? Or is something else in operation there? So we always aware, am I multiplying, am I?
Hello, Mindsetters, grade 11s. You guys were in grade 10 last year. Now you're in grade 11. So welcome to Maths. It is a Monday and you're hanging out with Looney and Dina. Dina, how are you?
Doing very well, doing extremely well, and even better for seeing you and everybody that's watching.
All right. So what are we doing for the grade 11s today?
Grade 11s, we're going to start off with that very famous topic, exponents. We're going to look at today some expressions, simplifying expressions, and next week we'll look at some equations.
All right. Cool, grade 11s, you heard it. I hope you guys are excited because it's your first live lesson for 2014. Just a reminder on where to get us and how to do everything. Learn Extra on Facebook and Twitter. That's where you follow us and like our page. And then you can go to learn.mindset.co.za to get your notes, to see the schedules, and to see all the videos for the lessons. Okay, guys? So I won't waste any more time, and I'll take it straight back to Dina.
Well, as I was saying, we're going to be looking at some exponents and some surds, some work that you've done previously, and also perhaps some new things that you'll be learning this afternoon. So let us adding, because the laws for addition and the laws for multiplication are very, very different. Okay, then we can actually go down here and just see. The other very famous one is one you've done in grade 9, and that is that an a to the 0 is always equal to 1, or any base to the power of 0 is 1. And then the definition of a negative exponent, which is the reciprocal of that power. So a negative exponent always tells us that something, that the power, you are going to take the reciprocal of the power when you place it into a positive format. Okay, so I think those are very common. Where the problem comes is in the application of it, and we'll look at it later, how we can stress the importance of the products and the sum. Now, this looks a little bit incorrectly written. Let me just rewrite that. That should say a to the power of m over n, which means that you have a rational exponent. Rational exponent means it's a fractional exponent. So this will exist when our base is positive, and when it's around the sum and difference of terms don't exist. And I find that the biggest problem with this section, or that students battle with, is really understanding that there are laws for products and factors that don't work for the sum and difference. And if you really try and analyze the kind of question you have in front of you and ask yourself, am I dealing with a product or am I dealing with a sum, then I think your work around exponents will be a lot more simplified, because you'll know when to apply the laws. So what I find that students do is they use the product laws when they're doing additions, or they'll use addition laws when they're doing products. They're not working with the correct law. So you really do have to pay attention and understand that the laws work around the product of the same base, which means we're dealing with one term. So the law is around the product. So I must first establish, have I got a product before I can jump into that law? And over here, you've got the quotient. So here, it's the quotient rule. Then you've got another slightly different looking law, and that is when a power is raised to another power, then if you really had to rewrite, find what we're going to be doing in the lesson today. So in this lesson, we're going to simplify expressions using the laws of exponents, and we're going to also add, subtract, multiply, and divide some simple surds as well. And whenever you do surds, you're going to not be using a calculator. So we're going to see how that all works. Then this year, we'll start off with our challenge question. We're going to first provide you with some really interesting questions that you can be working through while we're working through the various segments. And at the end of the show, we'll see if you were able to get it. So the challenge question is to simplify that fraction, 5 to the power of 2014 minus 5 to the power of 2012 minus 24, all divided by 5 to the power of 2012 minus 1. Let's see who's got the fastest finger and can post their answers the quickest. While you are working on that question, we're going to take you firstly through a little section on the summary of the notes that some of you may have already been doing in class, and then also one or two of the questions. So let's look at some of our exponential laws. Our laws are really centered around products and quotients. The exponential laws